perspective. The recent past heralded a boom in discovering exoplanets. There are 4,370 exoplanets discovered in over 3,000 planetary systems so far. In addition to these, more than 3,000 objects are awaiting confirmation of their exoplanet status. Most of them are large bodies, gas giants, super-Jupiters and super-Earths. This is accounted for by technical features of the technologies used for the purpose. It is easier to look for massive bodies with a short orbital period than to try to spot smaller planets similar to the Earth or Mars in terms of dimensions. There are among exoplanets those that may realistically harbor life. There are dozens of these objects scattered in space, and they understandably draw scientists' close attention. Today we're going to look at one of these objects, which is an exoplanet dubbed Gleis 832c. In fact, this exoplanet is one of the most likely places where alien life forms will eventually be detected. This exoplanet orbits a star called Gleis 832, which lies 16 light-years away from the Sun and is part of the Grus constellation. Gleis 832 is a dim red dwarf whose luminosity is just 0.7% of that of the Sun. Both its mass and diameter are approximately 2 times smaller than those of the Sun, and its temperature reaches about 3,300 degrees Kelvin. That is the reason why the habitable zone of this planet is within quite a short range from its star. Due to tidal forces, the planets lying in the habitable zone of Gleis 832 will be tidally locked to their star, that is, will face the star with one side only, just as it is the case with the Moon and the Earth, and Mercury and the Sun. There are 2 confirmed planets orbiting Gleis 832. The Jupiter-like planet Gleis 832b was discovered first. Astronomers announced the event in 2008. With the mass 2/3 that of Jupiter, the planet orbits its parent star at a distance of an average 3.4 astronomical units, completing a full orbit every 9.4 Earth years. The discovery of the other confirmed planet, Gleis 832c, was announced in 2015 by an international team of scientists headed by Robert Wittenmeyer. It got an exceptionally high rating for its similarity to the Earth, 0.81 to be more exact, which instantly attracted both scientists and reporters. It was also nicknamed the Second Earth, even though the 2 planets' parameters are rather different. Either way, this is one of the planets closest to the Earth with such a high Earth similarity index. The mass of Gleis 832c is 5.5 that of the Earth. It takes the planet 35 Earth days to complete a full orbit around its parent star, moving at a distance of an average 0.16 astronomical units. This is 6 times less than the distance between our Earth and the Sun. Its orbit's eccentricity is rather high, with the planet regularly leaving the habitable zone and then re-entering it. This must cause sharp temperature leaps and drops on its surface. Gleis 832c is estimated to receive approximately as much energy flux from its parent star as does the Earth from the Sun. The average surface temperature on the planet is 253 degrees Kelvin or 20 degrees Celsius below zero. It is also suggested that due to the atmosphere, which is likely to be quite dense, the temperature on the planet may be considerably higher. However, it is not easy to claim this with certainty, as Gleis 832c lies quite close to its star, and so chances are it is firmly tidally locked to it. In this case, there should be a substantial temperature difference between its sunny side and shadow side, which should regularly cause hurricane winds if the atmosphere really is dense. It's worth mentioning that in 2017, following observations, astrophysicists from the University of Texas at Arlington, the USA, put forward the hypothesis that there may be a third planet in the Gleis 832 system. Its mass could be 1 to 15 Earth masses, and it could follow a stable orbit around the center of the system 0.25 to 2 astronomical units away from it. At the moment, the planet is being searched for. Let's imagine what Gleis 832c would look like assuming life were possible on this planet. First of all, we wouldn't help noticing its gravity, which would be strikingly higher than that on our Earth. Since the planet's diameter is not yet known, the gravity force cannot be calculated exactly. Still, it would be a rocky planet similar to our Earth and Earth-like planets in terms of its density, so its gravity force would be likely to reach 200 to 400% that of the Earth. This would lead to the relief leveling out, meaning that the mountains would not be so high and the oceans not so deep. This in its turn would enhance the area of warm water, which is favorable for life. Due to a dense atmosphere and a comparatively dim sun, the landscape on Gliese 832c would be of a reddish hue, and in general the planet would be submerged in semi-darkness. Since the planet is likely to face its star with the same side at all times, the temperature on the sunny side should be high and the temperature on the shadow side quite low. In the ring-like area at the border between them, the temperature should be moderately comfortable, although due to regular heating of the planet, the atmosphere would be constantly in turmoil, which should result in strong winds. In addition, high objects of relief potentially able to dissipate some of the force of hurricane air currents fail to form on account of high gravity conditions. As the orbit of Gliese 832c is small and elongated, seasons on this planet should change every week. It will be winter on Gliese 832c at the furthest point from its parent star, and summer at the closest approach. The tilt of the rotational axis with respect to the ecliptic plane will not be of such importance as it is in the case of the Earth. The change of season will depend exclusively on the planet's getting closer to or away from its parent star. The most favorable conditions for life to develop on Gliese 832c are likely to be in the ring-like area at the border between the light and the dark sides of the planet. It is here that most liquid water will accumulate and rain down from clouds formed on the warm side. Ice caps on the dark side will also melt in the border zone, thus supplying still more water. It goes without saying that it is water that is key to developing life. The change of seasons will be likely to play the same role as lunar tides on our Earth, with areas alternately submerging and re-emerging. This process of water getting mixed with substances dissolved in it is a good prerequisite for life to originate and develop. There is a good chance of life originating in water and probably staying in it without later spreading to land. The ocean reduces the effect of gravity and protects its potential inhabitants from sharp temperature changes and hurricane winds. As for frequent and sharp changes of seasons, hypothetical organisms on Gliese 832c may learn to lapse into a state of anabiosis in order to weather unpleasant, although short, periods of high and low temperatures. Alternatively, they may choose to emigrate to a comfortable temperature zone, from the sunny side to the shadow side and back again, for example. If a space probe ever reaches the surface of Gliese 832c to investigate the area, what would it see there? Assuming life did originate on this planet, as the gravity forces are rather strong there, the potential inhabitant should be a thick-set, chunky figure boasting a robust skeleton and powerful muscles. Plants on Gliese 832c would be dark in order to attract as much light as possible. They should also be quite low and likely to be creeping or moss-like, with strong roots able to stand winds. It is highly likely that rather than chlorophyll, some other molecules should be important for photosynthesis. The planet's dense atmosphere may become a habitat for bizarre life forms floating in air currents. Single-celled microorganisms, for instance, may float in this dense atmosphere following air currents, while capturing light and nutrients dispersed in the air. Because of a dense atmosphere, high clouds and a dim sun, the surface of Gliese 832c would be a rather dark place. Life forms would have to adapt to these conditions. Vision would probably not play the decisive role in their existence, if it evolved at all. Alternatively, its spectrum may be limited to the infrared range. Be it as it may, all these speculations remain conjectures and ideas, even though they're based on good physical laws and assumptions. I wonder which of these suggestions you would call realistic and which of them bordering on fantasy. Or perhaps Gliese 832c is not habitable at all? Let us know in the comments and let's keep in touch.